Summer 2019, Paper 3, Calculator. So once again, I've got all my materials ready. I've set my calculator up so it is working. I've checked it. Everything is as it should be. So let's start the paper. Question 1. Write 478 to the nearest 100. So we're rounding for this question. Nearest 100. 478. We're going to the nearest 100, so I'm going to put my split line for the rounding after the hundreds. This number here, the 4, is the one that's either going to stay as it is or change. Our number is either going to stay as a 400 or it's going to change to be a 500. To work out which one of those we need to do, we look at the number after the split line. That's the tens number in this case. It is a 7. 7 is more than the 5 halfway point, and if we're more than that 5 halfway point, we must be closer to the upper limit than the lower limit, so we must be closer to the 500. And 478 to the nearest 100 is 500. Question 2. Write down a multiple of 8 that is between 41 and 60. Multiples, we're thinking about our times tables, so we need something from the 8 times table that is between 41 and 60. Maybe I could write out my 8 times table until I get to something that's in that gap. We're going to start with 8, and then 16, 24, 32, 40, 48, 56, 64. 56 would also be fine. Either of those two would be okay, so you could have either 48 or 56. And bear in mind that even if you do not know your 8 times table, you could always work it out on your calculator. You could start with 8 and then add on 8, add another 8, add another 8, and repeatedly add 8s until you get to something that's within that gap, 41 to 60. Question 3. Change 1.5 kilometers to meters. Whenever we're doing any unit conversions, we need to start off with the single fact that's going to help us. So we have that 1 kilometre is 1,000 metres. That is our basic starting point. From that, we can also say then that if 1 kilometre is 1,000 metres, 2 kilometres will be 2,000 metres. Key thing there is that 1.5 is exactly halfway between 1 and 2 kilometres, which means the conversion to meters will be exactly halfway between 1,000 and 2,000, meaning we are at 1,500 meters. Notice also that the 1 and the 5 are contained in the meters conversion. We've got the same digits. The place value has changed, the decimal point has vanished, and we've gained some zeros. But the 1 and the 5, the digits are still there, and they are still in the same order, 1 and then 5. So 1,500 meters. Question 4. Here is a list of numbers. 4, 6, 9, 10, 15, 27, 30 and 40. From the list, write down all the numbers that are powers of 3. So we're focusing on powers of 3 then. So that's multiples of 3. 3 multiplied by itself a given number of times. So we've got 3 to the power 1 is 3. 3 squared. 3 times 3. 9. Well, 9 is in the list. So 9 is a power of 3. 3 cubed. So that's 3 times 3 times 3. 27. Also in the list. So 27 we can write down. 3 to the power 4 would be 3 times bigger than 27. 3 to the power 4 would be 81, which is far too big. So 9 and 27 are our only possible answers. Notice that there are some numbers in here that are multiples of 3. They are things in the 3 times table, the 6, the 15, the 30, plus the 9 and the 27. In fact, they have been put there deliberately to check that you know what powers are. And bear in mind as well, you could do the powers on your calculator using the powers button. Something like this, or whatever your calculator uses for the power button. Question 5, write 19% as a fraction. Well, the key thing there is this symbol, this percent. Percent literally means out of 100. So to turn it into a fraction, we simply need to write that 19% is 19 out of 100. We're not asked to cancel it down. So we can just leave it at that. In fact, it won't cancel down. That is already the simplest form. 19 is a prime number. The only things that will divide by 1 and 19. 1 won't change anything, and 100 won't divide by 19. Question 6. Work out 20% of 80. Well, the key thing is we're starting off with 100%, and 100% is the 80. We could work out lots of simple percentages from there that would be useful. The most useful one to work out would probably be 10%. How are we going to work out 10%? Well, to find 10%, we can divide our 100% by 10, because we need 10% to make 100. We're not dividing by 10 because it is 10%, we're dividing by 10 because we need 10 of them to make the 100%. So if we divide by 10, we'll have to divide by 10 here as well, and we'll find that 10% is 8. We didn't want 10% though, we wanted 20%. Well, if 10% is 8, another 10% would be another 8, giving us 20% overall, 2 lots of the 8, 16. And 20% of 80 would be 16. Question 7. There are 4 types of counter in a bag. The table shows the number of each type of counter in the bag. So we've got type of counter, we've got red circle, red square, and green square. The number of counters given as 16, 26, 11 and 7 respectively. There are more green counters than red counters. How many more? Well, to work out how many more green counters than there are red counters, we need to know first of all how many green counters there are, and second of all how many red counters there are. So green counters will be 26 plus the 7 comes to 33. And red counters will be 16 of the red circles and 11 of the red squares. Add those together, 27. So then the difference will be 33. Take 27, which will neatly come to 6. Question 8. Here is the gauge for the fuel tank of a car. The fuel tank holds 52 litres of fuel when the tank is full. The tank is 1/4 full of fuel. Work out how many more litres of fuel are needed to fill the tank. Might be useful then to work out how much fuel is already in the tank. So if the tank holds 52 litres of fuel when the tank is full, and there's only 1/4 of the tank full, we probably need to work out 1/4 of 52. Well, to find 1/4 of something, we're going to divide it by 4. So there are 13 litres of fuel in the tank already. That means then we need 52 minus 13 is 39 litres of fuel to fill the tank. Notice also that we could say that if there is 1/4 of the tank full, there is 3/4 of the tank left, and we could try and find 3/4 of 52. Well, if 1/4 is 13, then 3/4 will be 3 lots of 13 is also 39. Either way will work, either way will get you the marks. Question 9. Simplify 4e plus 6f plus 7e minus f. So simplify, we're looking at collecting together as much of the information as we can as possible, writing this in as simple a way as we can. Something like this, where we've got different symbols and we've got different signs going on, we need to make sure that each sign stays stuck to the term that it's attached to. So we're going to start boxing things off. We're going to start at the right hand side. We're going to box off the f and the minus. We're going to box off the 7e and the plus in front of it, the 6f and the plus in front, and the 4e at the front. There isn't a sign there. It must be a positive because it isn't a negative 4e. I'm now going to move these boxes around. The box contains a term and the sign that's stuck to it. So as long as the stuff that's inside the box stays, I can put them wherever I like. So I'm going to move all of the e's over here first, and then I'm going to move all of the f's over here. So over here we've got the 4e, and we're going to have the plus 7e. And over here we're going to have the plus 6f, and we're going to have the minus f. I'm going to start with the e's. I'm going to collect them into one single term. So I've got 4 e's, and then I'm adding 7 e's. Well, that will take me to 11 e's. Over here with the f's, I've got 6 f's plus 6 f's, and then I'm taking off an f, which will leave me with plus 5 f's. I'm going to keep the sign because I'm going to need to put these back at the end. I just need to write these next to each other now. So I've got 11 e's plus 5f. And there is my simplified answer. I can't combine those anymore. They are different letters, they are different currencies. Question 10. Bill has 400 counters in a bag. He gives 35 of the counters to Samina, 50 of the counters to Henry, 75 of the counters to Lucas. What fraction of the 400 counters is left in Bill's bag? Give your fraction in its simplest form. Okay, so we need to write down the fraction of the 400 counters that's left in Bill's bag. Well, to do that, we're going to need two numbers. On the bottom of the fraction is going to be the 400, because that's how many it's out of. And on the top of that fraction, before we can cancel it down, we need to know how many counters are left. It's the number of counters left out of the 400. So we need to know how many are left. So our first step will be to work out how many he's given away. So I'm going to do 35 plus the 50 plus the 75 to work out how many he's given away. And that means he's given away 160 counters. So he has now got counters left will be the 400 less the 160, 240 counters. So he has got 240 counters left. I can now write down the fraction of the counters that are left. 240 out of 400, i.e. 240 over 400. That is a perfectly acceptable fraction. Up to this point, 2 marks probably, but we need to give our fraction in the simplest form. So I need to cancel that down. I need to look for something that top and bottom will divide by. There are probably 2 obvious things that top and bottom will divide by. They're both even numbers, so they will both divide by 2. Alternatively, they both end in zeros, which means they will both divide by 10. I'm going to go for the divide by 10. You could do it with divide by 2, you'd still get there in the end. I'm going to go for the divide by 10 top and bottom. So 24 and 40. They are both even numbers now. They are much smaller. But with both being even numbers, I could divide by 2 and get 12 over 20. I could do it again by 2 and get 6 over 10. And they're still even. So I could do it again and get 3 over 5. That last one is the hardest spot. A lot of people will get to 6 over 10 and stop and not recognise that they can cancel it down once more to get 3 over 5. But it turns out that 3/5 of the counters are left in Bill's bag. Question 11. The table shows the costs of sending a parcel by the express service and by the rapid service. The express service is £15.25, the rapid service is £35.38. Brendan has to send 12 parcels. It will be cheaper to send the parcels by the express service than by the rapid service. Part A, how much cheaper? Well, to work out how much cheaper something is than something else, we need the 2 overall costs so that we can then compare them. So we're going to need to work out the cost of sending the 12 parcels by express and the cost of sending the 12 parcels by rapid, so that we can then work out how much cheaper one is than the other. So step 1 then, the express first. One parcel is £15.25, so 12 parcels will be 12 lots of £15.25. We'll put that in our calculator and we're going to find that that comes to £183. Step 2 then, the rapid service. 12 lots of £35.38. One parcel is £35.38, so 12 parcels will be 12 times that. We're going to put that in our calculator and we're going to find that that comes to £424.56. The question asks us how much cheaper it is. We've got the 2 prices, we just need to do the larger one, taking away the smaller one. Price for rapid, taking away price for express, so £424.56. less the 183, pop that in our calculator, 241.56, and our answer then is £241.56. Luke wants to send 21 parcels by the express service. He does the calculation 20 times 15 equals £300 to estimate the cost. Part B, explain why Luke's calculation shows the actual cost will be more than £300. So what he's done to estimate is he's rounded down the number of parcels. He said, well, let's call 21 20. And he's rounded down the price. The actual price of the Express is £15.25. He's called it 15. If he has underestimated the cost, which he has, and he's underestimated the number, which he has, if he's underestimated both, his final answer of £300 must also be an underestimate. And that's why his calculation shows that the actual cost will be more, because he has underestimated both the number of parcels and the cost of postage. He has underestimated both the number of parcels and the cost of postage, so the final answer will be much bigger. It will cost more for each parcel, and there's an extra parcel unaccounted for. Question 12. Ali, Ben and Kathy share an amount of money in the ratio 6 to 9 to 10. What fraction of the money does Ben get? Now this is an interesting question because it's a ratio question, except it isn't really. It's a fractions question. Why is it not a ratio question? Because it doesn't give us an amount of money to share out. You have got two options with this question. You could pick a standard value to then share in this ratio. Find out how much of that amount, any amount of your choosing, but preferably something that divides nicely. Pick an amount of money, work out how much of that money Ben would get, and then work out what fraction the amount of money Ben gets is of the original amount that you picked. You could test it out with a value. Or you could do it in terms of the number of parts that it's been cut into. There is some money. There is the money. And that money is being shared out 6 and 9 and 10 each time. It doesn't really matter what their overall amount is going to be. Each time we're taking some money out, Ali's getting 6, presumably pounds, Ben's getting £9, and Kathy's getting £10. Each time we're doing that, we are taking out 6 and 9 and 10 is £25, and we're splitting that £25 among the three of them. Well, Ben is getting 9 out of the £25, so he must be getting, Ben gets 9 out of 25, and the key thing there is the 9 out of 25. If he's getting 9 out of 25, surely he's getting 9/25 of the money. If he's getting that every share, but if he's getting that every share, he's going to get 9/25 of the overall share. Question 13. The first term of a sequence of numbers is 24. The term-to-term rule of this sequence is add 8. Josie says, no number in this sequence is in the 5 times table. Give an example to show that Josie is wrong. If we're being asked to give an example, presumably, especially given that it's a 1-mark question, just running through the first couple of numbers of the sequence will yield an example that proves Josie wrong fairly quickly. So if we start with 24, there's our first term. The next number, we're going to add 8, so the next number would be 32. That is not in the 5 times table. The next one up will be add 8 again, and we get 40. 40 is in the 8 times table, because 40 is in the 5 times table, because 40 is 8 lots of 5. So our example, 40 equals 8 times 5. It's a number in the sequence that is in the 5 times table. Part B. Is 85 a number in this sequence? Give a reason for your answer. We don't need to go overcomplicate on this. We could just keep the sequence going. We're already at 40, 85 isn't much bigger. So if we're at 40, the next one will be 48, and then 56, and then 64, and then 72, and then 80, and then 88, and 85 is clearly not in the sequence because it would be in there. We probably do need to give something a little bit more than just, well, we've tried it out and it wasn't in the sequence. Hopefully we'll recognise something about these numbers. 24, 32, 40, 48, 56, 64, 72, 80, 88. It's the 8 times table. It's the 8 times table, but starting at 24. So if we say that our sequence is the 8 times table, starting at 24, then there won't be an 85. Backed up by the fact that we've tested out the sequence. We've continued the sequence until we've shown that there isn't an 85 in it. Question 14. Find the value of 5.27 plus 3.5 over 7.9 minus 4.36. Give your answer as a decimal. Write down all the figures on your calculator display. Now the key with these kind of questions is to try and do as much as possible in one go. Because these are decimals, it is likely that things are going to start rounding themselves if you use your calculator too much. This one we could do in stages. We could do the top line, we could work out the bottom line in our calculators, that would be easy enough, and then do the division. We could also do it in one go, and I could do it in one go if your calculator will allow this, either using brackets or using the fraction button. Using the fraction button gives me the two sets that I could type stuff in on. 5.27 plus 3.5 on the top line. I'm going to use the arrow to move to the bottom line of the fraction now. 7.9 minus 4.36. At this point, if you are doing it this way, check that what is on your calculator looks exactly the same as on the page. That's why these calculators are quite good, because what's on screen should look exactly the same as on the page. If it does, then we can press equals, and we end up with this. 877 over 354. But the question quite clearly says give your answer as a decimal, so I need to press the S to D button. It's here on mine to convert to a decimal. 2.4774013. How much of that do I write down? Do I round it? No, I don't, because the question says write down all the figures on your calculator display. If it asks you to write them all down, then write them all down. 2.4774013. As a note, if you wanted to do this one in separate stages or with brackets, you could do it with brackets. Bracket off the top line, 5.27 plus 3.5. Close your bracket, that's your top line done. Divide by, using that over there as a divide. Open yourself a bracket for the bottom line, 7.9 minus 4.36. Close the bracket, press equals, and we get exactly the same answer. You could also, with this one, 5.27 plus 3.5 on the top, 8.77, make a note of that. 7.9 minus 4.36 on the bottom, 3.54, 8.77 divided by 3.54, and we get exactly the same answer again. 3 different ways of doing it. For this question, it will not make a difference which one we choose, as long as you write down every single digit on that calculator. Question 15. You can use this rule to work out the total hire charge in pounds for hiring a 3D printer for a number of weeks. So total hire charge in pounds is number of weeks times 70 and then plus 50. How do I know it's and then plus 50? Think about your BODMAS. We've got a times and we've got an add. Brackets, power, divide, multiply, and then add and subtract. So the multiply would come first. We'd do the number of weeks times 70 and then we'd add 50 at the end. Mia wants to hire a 3D printer for 4 weeks. Work out the total hire charge. So the total, according to the rule, is going to be the number of weeks, so that's 4 times 70, and then plus 50. And again, we're going to do the times first by our BODMAS. 4 times 70, 280, plus the 50, £330. Zahir hires a 3D printer. The total hire charge is £680. Part B, for how many weeks does Zahir hire the 3D printer? It may not look like it, but this is kind of an algebra question. It's working from a total back to some information that we need to find out. Let's fill in what we already know. 680 is equal to a certain number of weeks that we then times by 70 and we added 50, i.e. we've taken an unknown number, we've timesed it by a certain thing, 70, then we've added on a total 50 and we've got 680 out as the answer. This is a function machine question. So the number of weeks times 70, add 50, gave us 680 out the end. If we work backwards, we can get back to the number of weeks. So 680 goes back in the function machine, we take off the 50, we divide by 70, and that will give us our number of weeks. 680 less the 50 is 630. 630 divided by 70, pop that in our calculator perhaps, 9 weeks. Question 16. Here is a rectangle. So 4 centimetres across the top and bottom, 6 centimetres on the left and right. The 6-sided shape below is made from 2 of these rectangles. Work out the perimeter of this 6-sided shape. Perimeter then. So imagine we start walking from one corner and we walk around all 6 of the sides, one at a time, until we get back to where we started. That is the perimeter. So we're going to need to know the lengths on these sides. Big clue there, it is a 6-sided shape, so we're going to need to know the lengths of 6 sides. Let's fill in what we can from the diagram. Well, this one here is going to be 4, because it's just the width of the rectangle. This little one here, we're not sure about that one, we'll come back to that one in a bit. This one here, 6. This one here, 4. This one here, well, there's 6, and there's 4, so the whole thing will be 10. And this one here, 6. 1, 2, 3, 4, 5 sides filled in. We just need to fill in this little one here. How long is that going to be? Well, this whole side here is 6, and this little bit here is 4. 6 less the 4 will leave us with 2 for that side there. So the perimeter then is going to be 4 plus 2 plus 6 plus 4 plus the 10 along the bottom plus the 6 up the side. 1, 2, 3, 4, 5, 6. All 6 sides accounted for. 4 and 2 is 6, plus the 6 is 12, plus 4 is 16, 26, 32 centimetres. You could of course put that in your calculator. Question 17. The accurate scale diagram shows a telephone mast and a box. The box has a real width of 1.5 metres. Find an estimate for the real height in metres of the telephone mast. Keyword there, accurate scale diagram. That means that the size of the telephone mast compared to the box in the drawing matches up to the size of the telephone mast and the box in real life. So however many times bigger the telephone mast is in the drawing is the same as the number of times bigger in real life it is. That unlocks our way to do the question. We're going to ignore the 1.5 metres for now, and we're going to find out how big the box is on the drawing. So using my ruler, I'm going to measure that the width of the box is 1.567, about 1.8 centimetres wide. I'm not going to link that to the scale yet, I'm going to do this in a much simpler way. 1.8 centimetres wide. I'm now going to measure the height of the telephone mast. The telephone mast comes to a height of 10.567, 10.8 centimetres in height. 10.8 centimetres in height. Step 1 then. 10.8 divided by 1.8. Pop that in my calculator. 10.8 divided by 1.8 comes to 6. That means that the height of the telephone mast is 6 times bigger than the width of the box. So the telephone mast is 6 times the width of the box. But if it's 6 times the width of the box on the diagram, then it must also be 6 times the width of the box in real life, which means the approximate height must be 6 times 1.5 meters is 9 meters in height. Question 18. The table shows information about the numbers of points scored by 30 students in a quiz. Part A. Find the modal number of points. Modal number of points, so the mode, fancy way of asking for the mode, we want the number of points that has the highest frequency. So the biggest of these numbers is the 7, which means the modal number of points must be not 7, because we need the modal number of points, so it will be the number of points attached to that highest frequency, i.e. 2. The modal number of points is 2 because it has the highest frequency. Part B. Work out the total number of points scored. To do something like this question, we need a very strong understanding of what the table is showing us. The table is showing us different numbers of points. So some people scored 0, some scored 1, some 2, some 3, some 4, and some 5 points. The frequencies are showing us how many times those points were scored, as in how many of the 30 students scored that many points. 4 students scored no points, 3 students scored 1 point, 7 students scored 2 points, and so on. We can use that to help us work out the total number of points. We need to add all these up quickly, so we're going to be doing 0 and 0 and 0 and 0, and 1 and 1 and 1, and 2 and 2 and 2, and 2 and 2 and 2 and 2, and 3 and 3 and 3 and 3 and 3, and 4 and 4 and 4 and 4 and 4 and 4, and 5 and 5 and 5 and 5 and 5. To do it quicker, surely we could just say we've got 4 lots of 0, 3 lots of 1, 7 lots of 2, 5 lots of 3, 6 lots of 4, and 5 lots of 5. We could just times each of these together and have that many lots of the number of points. So we've got 4 lots of no points. 4 students with no points is no points in total. 3 students with 1 point, that's 3. 7 students scoring 2, that's a total of 14 points. 5 students scoring 3, so that's 15 points. 6 students scoring 4, so that's 24 points. And 5 students scoring 5, which is 25 points in total. If we now add these up and do 0 plus 3 plus 14 plus 15 plus 24 plus 25, perhaps on our calculators, we will get the total number of points scored, and we will find that that comes to 81 points. Question 19. Make x the subject of the formula y equals 2x plus 4. So we have a formula given to us, a formula using x inputs to find y outputs, y equals 2x plus 4. The subject of the formula is currently y, because it is a formula designed to take an x value and find a y value. We need to rearrange, change the formula, rewrite the formula so that it's now a formula about x using y inputs. To do that, we need to build a function machine. So we start with the x. We start with what we're trying to make the subject. The first thing that happens to x, to make the formula, because we need to build our function machine going forwards first, the first thing that happens to the x is it becomes a 2x, i.e. we times it by 2. Then we add 4, and in doing those 2 steps, we split y out the end. We can now reverse the formula. We can now reverse the function machine. So y goes back in. Instead of adding 4, we take 4 off. And instead of timesing by 2, we divide by 2. So we run that back through. Y take away 4. The best thing we can do is to write that as y take away 4. We can't simplify that anymore. They're 2 different things. One is a letter, one is a single number. The best we can do is write it as y take away 4, but that's okay because we're rewriting a formula. We're then going to divide the whole thing by 2. Well, we don't really need to get particularly fancy with this either. We can just write that as y take away 4, all of which is divided by 2. That's the output we get when we reverse the formula, which means it must be the same as the x that went in. So our rearranged formula with x as the subject x equals y minus 4 all divided by 2. Question 20. The diagram shows a square ABDE and an equilateral triangle BCD. Work out the size of angle EBC. Something to notice here, we don't need to give our reasons for this. It's only a 2-mark question. We just need to get from the information in the question to the answer, EBC. As with any of these questions though, we are going to have a look at the diagram first of all. We're going to unpick as much as we can from the diagram and then we're going to check the words. So we've got, from the diagram, we've got a square ABDE. We know it's a square because it tells us in the question it's a square. So maybe that's worth highlighting there. ABDE. We've also got a diagonal up through it. So there's a diagonal there. We also have here a triangle. Triangles are particularly useful and worth spotting. So there is a triangle, B to C to D. We know what kind of triangle it is, in fact. It's an equilateral triangle. If it's an equilateral triangle, that tells us something about the sides. It tells us that the sides are all the same length. And if the sides are all the same length, then the angles inside it are all exactly the same size. That's it for the diagram. We haven't got any angles given to us. Now that means we're going to have to use rules of angles, properties of the shapes, to be able to unlock the question. Well, first thing I'm going to do is I'm going to notice what angle it is we need to find. I need to find EBC, so that's E to B to C, and then the angle between them. Helpfully, it's already been labelled for us there. It's this whole thing. Now this whole angle here in pink is made up of 2 separate angles. It's made up of this one here, this little bit in the corner of the square, and it's made up of this one here from the triangle. Well, that's how we need to work it out. If we can work out the 2 separate bits, we can add them together and get the whole angle. So step 1, I'm going to work out this bit here. It's within the square. Now we know something about the angles in a square. The angles in the square are 90 degrees. Here is a right angle in the corner there, a 90-degree right angle. This is the diagonal of the square. It means we're cutting that right angle in half. So I can take 90, I can divide it by 2, and I can get 45 degrees. And there is my first part of the angle, 45 degrees there. Step 2, I could work out the angle in the equilateral triangle perhaps. We know something about the angles in a triangle. The angles in any triangle, any at all, will add up to 180 degrees. And if this is an equilateral triangle, the 3 angles will be exactly the same. So I can do 180 divided by 3 to give me 60 degrees for that angle there. Final step then, the whole thing must be 45 plus 60 is 105 degrees. And looking at the diagram, 105 degrees, that looks reasonable for that as an angle. Question 21. Liz goes on holiday to South Africa. Liz wants to change £850 into South African rand. She wants to get as many 200 rand notes as possible. The exchange rate is £1 equals 18.53 rand. Work out the greatest number of 200 rand notes that Liz can get for £850. Okay, so there's 2 steps to this question. The second step is to work out how many 200 rand notes she can get. Well, the first step is to work out how many rand she is entitled to in total from the £850. Because once we know how many rand she would get for the £850, we can work out how many 200 rand notes she needs to make up that value. So our first step then is to recognise that £1 is the same as 18.53 rand. And I'm going to write that as a ratio. You might prefer to write it with an equals, but I'm going to write it as a ratio. So I know that for every £1 she's getting 18.53 rand. Now she is getting £850 worth in total. So what we've done is we've scaled our ratio, we've times it by 850 to get from £1 to £850. That means we're going to have to times the number of rand by 850 as well. £1, £850 worth, 18.53 rand for each pound, 850 lots of the 18.53. So I'm going to pop that in my calculator, 850 times 18.53, and I'm going to get 15750.50 rand. So that's how many rand we get in total for our £850. She's going to get that in 200 rand notes. Now she can only get 200 rand notes up to the value of 15,750 and a half rand. We need to know how many 200 rand notes she can get. So I need to know how many 200s there are in this many rand. So I'm going to divide by the 200. And then dividing by 200, I'm going to get 78.7525. There are 78.7525 200s in the total number of rand that we would get for our £850. So how many 200 rand notes can she get in total? Well, 78. Why not 78.7525? Well, because you can't have 0.7525 of a note. She will either get 78 rand notes or she will get 79 rand notes. And while the 0.7 might suggest that we round up to 79, if we rounded up to 79, she will be getting more rand notes than she is entitled to. She can only get 200 rand notes up to the value of this many rand. So she can only get at most 78 200 rand notes. Question 22. In October, Sally drove 560 miles in her car. The car travelled 34.5 miles for each gallon of petrol used. Petrol cost £1.08 per litre, and 1 gallon is 4.55 litres. Work out the cost of the petrol the car used in October. Okay, quite a lot going on with this question. We're going to work backwards from the end to work out what we need to do and what we need to work out. So we need to work out the cost of the petrol that the car used in October. Well, to work out the cost, we are given cost information. We're told that petrol is £1.08 per litre. To work out the cost, we need to know how many litres it used then. Because once we know how many litres we used, £1.08 per litre, and we can scale up to find the total cost. So we need to know how many litres we've used. Problem is, we are given information here about the distance travelled, and we're told that 560 miles, 34.5 miles for each gallon of petrol used. Here we're talking about gallons, and here we're talking about litres. The cost information, we need to have our petrol use in litres, but the distance information given to us at the beginning that will let us find how much petrol we've used, we're talking about gallons. And this is why there is this piece of information here. 1 gallon is 4.55 litres. So what we're going to have to do, step one, is we're going to have to work out how many gallons of petrol we used. Because if we can work out the amount of petrol we used in any unit, we can do some converting later on. So to find the number of gallons of petrol used, well, she drove 560 miles in her car. And the car travelled 34.5 miles for each gallon of petrol used. So 1 gallon of petrol, she travelled 34.5 miles. A second gallon of petrol, another 34.5 miles, and so on. So we need to know how many 34.5s there are in 560, because that will tell us how many gallons of petrol we used. So the number of gallons is 560 divided by 34.5. Because knowing how many 34.5s we need to get up to the 560, that will give us the number of gallons used. So 560 divided by 34.5, 16.23188. And I'm going to keep that information there. I'm not going to round yet. I'm going to do any rounding at the end. I'm going to keep things a little bit more accurate than I need them to be so that my answer is more accurate. So we now know how many gallons of petrol we've used. We need 16.23188 and so on gallons of petrol. That's 16 lots of the 34.5 to get up to the 560 miles that Sally drove. We now know that 1 gallon is the same as 4.55 litres, and I've chosen to write this as a ratio. You might leave it as an equals if you prefer. I didn't travel using 1 gallon of petrol. I travelled using 16.23188, so I need to scale my ratio up. Now if I've scaled up by 16.23188 on the left, then I need to do the same on the right. I need to scale up the number of litres. So I'm going to do that. And I'm going to find that there are 73.85507 ... litres used. Again, I'm going to keep a few more decimal places around than I need in my final answer to keep things accurate. So what I've done is I've found out how many gallons of petrol I needed to travel the 560 miles first of all, and then I've converted the number of gallons used into litres. Why? Because the cost information is talking about litres. We're told that petrol costs £1.08 per litre. So I now know that I have used 73.85507 ... litres of petrol. I can now work out the cost of the petrol then. So if 1 litre costs £1.08, then 73.855 litres must be 73.85507 ... times the £1.08, 79.7634 ... or £79.76. The 3 after the 6 will mean I need to keep my answer as a £79.76 rather than round up to the 77, because 3 is less than that 5 halfway point. So £79.76, which seems reasonable for the cost of petrol over a month. It doesn't seem too wide of the mark. Question 23. Costco sells packets of mints to shop owners. On Monday, 3 shop owners buy mints from Costco. Each shop owner buys small packets, medium packets and large packets of mints. Alan buys 400 packets of mints. 32% are small, 40% are large packets. Beryl buys 500 packets of mints. 3/10 are small packets, 1/10 are large packets. Charlie buys 150 small packets of mints, so that the number of small packets to the number of medium packets as a ratio is 3 to 4. Work out the total number of medium packets of mints these shop owners buy. You must show all your working. Okay, there's a lot going on here. We've got 3 different shops, 3 different ways of working out chunks of the whole. We've got percentages for Alan, fractions for Beryl, and ratios for Charlie. However, the direction for the question should be reasonably clear. We need finally to work out the total number of medium packets of mints these shop owners buy. Now that says to us what we need to do is we need to work out the number of medium packets that Alan buys, the number of medium packets that Beryl buys, and the number of medium packets that Charlie buys. And if we can find those 3 numbers, we can just add them up at the end and have a total number of medium packets that all 3 buy. Where the difficulty lies is in setting out your answer and making sure it's clear what you've done. Why do we need to do that? Because you must show all your working, and in the fact that we are dealing with percentages, fractions and a ratio. What I'm going to do is I'm going to make it clear which shop I'm talking about. I'm going to do Alan first, and I'm going to work out Alan's first. Now we're dealing with percentages. So clearly 100% is the total number of mints that Alan buys, which is 400 packets. Now I need to work out the number of medium packets. I have got 2 choices for doing this. I can either work out the 32% that are small, work out the 40% that are large, and then find the rest of them, because the rest of them must be medium, or I can see what percentage I am left with and work out that percentage. It doesn't really matter which one we do. I'm going to go for working out these 2, because they are the 2 that are given to me, but I will prove at the end that it is exactly the same. So I'm going to work out 10% first of all. Now 10%, I'm going to divide the 100% by 10, because 10% make up 100%. So I'm going to find that 10% is 40. And I'm also going to find 1%, because that's probably going to be useful as well. So 1% will be 10% divided by 4. So 1% will be 10% divided by 10 and is 4. I'm now going to work out the number of small. So small will be 32%. So I'm going to need 3 lots of 10% and 2 1%. So my calculator, 40 plus 40 plus 40 plus 4 plus 4, 128. I'm going to work out the number of large. Well, large, I'm going to need 4 lots of the 10% because I need 40%, so that's 10, 20, 30, 40. So I'm going to want 40 and 40 and 40 and 40 is 160. Therefore, then, the number of medium must be whatever is left of the 400 after we've taken out the small and the large. So 400, take the 128, take the 160, will leave me with 112 medium packets of mints. Alternatively, I might have said, well, there's 40% and 32% already accounted for. 40 plus 32 is 72, so we need 28% remaining. I could then work out 28% of 400. Well, then I would want 10% and another 10%. That would give me 20%. I could even put in another one and have 30%. 30% will be 112. And if I take off 2%, 2% would be, well, 1% is 4, so 2% would be 8. Take away the 8 would also get me to 112. Either is fine as long as it's clear what you're doing. We should still get to 112 overall. That's Alan worked out. So I'm just going to rule off, make it nice and clear, and I'm going to work out Beryl now. So Beryl buys 500 packets of mints. I'm going to make a note of that. 3/10 are small, 1/10 are large, and the rest will be medium. Again, you've got two choices. You could either work out the fraction that is small, the fraction that is large, take those away from the 500 and see what you're left with, or you could work out the fraction that is remaining. I'm going to go for the first one again. So small will be 3/10. Well, 1/10 of 500 will be 500 divided by 10, because we're splitting into 10 parts, will be 50. So small, I want 3/10, so I want 3 lots of the 50, 150. And large, 1/10, so just 50. Therefore, medium will be 500, less the 150, less the 50. 150 and 50 is 200, so 300. Alternatively, you might say, well, there's 1/10 and 3/10 accounted for. That's 4/10 in total, so there must be 6/10 left. 1/10 is 50, so 6/10 will be 6 lots of 50, 300. And it works just the same. Final one then, Charlie. Now, Charlie buys 150 small packets, so that the number of small packets to the number of medium packets is 3 to 4. So, small to medium is 3 to 4. And we know that he buys 150 small packets. So what we can just do is we can scale our ratio up and find that missing number there for the medium. To get from small 3 to small 150, we must have times by 50 on the left, which means to keep the ratio the same, we must have times by 50 on the right. 4 times 50 is 200 packets of medium. We've got our 3 numbers now. So the total number must be 112 from Alan, plus 300 from Beryl, plus 200 from Charlie. 112 plus 300 plus 200, 612 medium packets of mints. Question 24, and we're given 3 sets here. We're given the everything set is 1, 2, 3, 4, 5, 6, 7, 8 and 9. We're given that set A is 1, 5, 6, 8, 9. We're given that set B is 2, 6 and 9. We're given a Venn diagram. We've got A and B labelled as circles. We've got the everything set here around the outside. And part A is complete the Venn diagram to represent this information. As with any Venn diagram question, the most important thing to do is to make sure we have a list of everything that needs to be in there somewhere. So we need to write out the information that's contained in the everything set. Now, it happens with this question that the everything set is just a list, so we know what needs to be in there somewhere. 1, 2, 3, 4, 5, 6, 7, 8 and 9 all need to be in that diagram somewhere, and as we place them in, we can cross them off in the everything set. We're going to try and fill in this bit here first of all, the bit that's in the middle of A and B, the stuff that is common to both A and B. So we're going to look at these two for A and B, and is there anything that turns up in both? Well, yes there is. 6 turns up in both, so 6 can go in the middle, because 6 there is contained within A, and it's also contained within B. 9 is also in both lists, so 9 can go in the middle as well. And again, 6 and 9 are contained within A, 6 and 9 are also contained within B. And 6 and 9 we've accounted for, so they can go off the everything set. We've put those in the diagram somewhere. We can now fill in the rest of the information from A and the rest of the information from B. So in A, we're left with 1, 5 and 8. Now they need to go in A, but they can't also go in B. So 1, 5 and 8 in there. And they are also used up from the everything set. From B, we've just got the 2 left. So that can go in B. And we've used that from the everything set. The only things from the everything set now that aren't anywhere in the diagram, we've got 1, 2, so 3, that needs to go out here. It needs to be in the everything set, it needs to be on the diagram somewhere, but it can't be in the circles. 4, because that's not in the circles, and 7. 3, 4 and 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, and everything is accounted for. So we've completed the Venn diagram. A number is chosen at random from the universal set E, the everything set. Part B, find the probability that the number is in the set A, N, B. So, it's important to recognise what A, N, B is. A, N, B, A and B, as in A and B both at the same time. So it's all the stuff that's in A and B at the same time, i.e. these two things in the middle. The 6 and the 9 are in A and B at the same time. So for our probability, we need to set up a fraction. We need a number on the top and we need a number on the bottom. The number on the top is the number of things that fit the criteria we are looking at. How many things are in A and B at the same time? Well, it's 2. It's the 6 and the 9, so it's 2. And on the bottom, we need the total number of possible outcomes. That's the total number of things in the diagram. The total amount of numbers that we can choose from. 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers to choose from. There are 9 numbers to choose from, and 2 of them are what we want, A, N, B. So 2 out of 9 for our probability. Question 25. Katie invests £200,000 in a savings account for 4 years. The account pays compound interest at a rate of 1.5% per annum. Calculate the total amount of interest Katie will get at the end of 4 years. Compound interest, keyword in this question there. Compound interest, interest on interest. So she puts £200,000 in a savings account. At the end of the first year, she gets a certain percentage of that given to her as interest, 1.5% of her money given to her, and she goes into year 2 with a new starting total. At the end of year 2, she gets another 1.5%, but it's not the same amount of money given to her, it's the same percentage, but not the same amount, because she's getting 1.5% on a larger amount of money, the total that she ended year 1 and started year 2 with. Same for year 3, same for year 4. So we're going to have to take this 1 year at a time. We're going to have to find 1.5% each time. This is where our calculator is going to be really important. 1.5% is a mucky number to find. So we're going to start off, I'm going to keep this nice and organised. Year 1, first of all. We start with £200,000. That is 100%. I need to get down to 1%, so maybe 10% would be helpful. 10% would be divided by 10, 2, 0, 0, 0, 0. £20,000. 5 zeros down to 4 zeros. We've lost one in the shift down the hundreds, tens and units grid. £20,000. So 1% then will just be £2,000. But we need to get to 1.5%. So we're going to have to go even further. We're going to have to break that down to 0.5%. 0.5%, half of 1%, so £1,000. We can then use that to find 1.5%. 1% plus the 0.5%, 2,000 plus 1,000 is 3,000. So she ends year 1 with 200,000 plus the £3,203,000. Now if that's what she ends year 1 with, she then goes into year 2 with a starting value of £203,000. So we need to do the same thing again. We need to break down to find 1% and 0.5% and then add them together to find the 1.5%, add that on. So 10% again, £20,300. 1%, divide that by 10, 2,030. And 0.5%, half of that, 1,015. You could be using your calculator for all this, bear in mind, I'm just skipping that bit out. 1.5%, add those two together. 2,030 plus 1,015 is £3,045. So she ends year 2 with £203,000 plus the 3,045, £206,045. Which means she starts year 3 with £206,045. And we're going to do exactly the same thing again. 10%, divide it by 10. £20,604.50. 1%, divide it by 10 again. £2,060.45. 0.5%, half of that. 1,030.225. I'm going to keep that there, even though, yes, we would need to round, obviously. I'm going to keep my decimals as we're going through, and I'm going to round at the end. Even though this is money, I'm going to round at the end. Add those together to find the 1.5%. £2,060.45 plus 1,030.225. 3,090.675. So she ends year 3 with her starting value, £206,045, plus that interest at the end of the year, £209,135.675. Getting a bit more complicated now, but this is particularly where our calculator use comes into play. So year 4 now. She starts year 4, £209,135.675. 10% then. We can divide by 10 to find the 10%. £209,113.5675. 1%, divided by 10 again, 2,091.35675, and 0.5%, 1,045.678375. Add those together to get the 1.5%, 3,137.035125. Again, getting particularly complicated. But this is because, getting particularly complicated, but if we are doing this on a calculator, it's not going to matter too much. They're all fairly simple calculations. Yes, they're quite long, but writing them down isn't that much of a pain either. So then we end year 4 with this starting value plus this 1.5% that we've just found, 212,272.7101. Now we can turn this into proper money. So we need to cut it off at 2 decimal places and round properly. So we end year 4, and thus the question, £212,272.71, because the 0 after the 1 is going to keep us at the 7-1 rather than round up to the 7-2. So our final answer, £212,272.71. Quite a complicated question, but just because it's 4 years and a 1.5%. Tricky number of years to deal with. With a calculator though, much more easy. And it's worth saying that if you had rounded here, if you had called this, say, 1030 and 23 pence, it probably wouldn't matter too much for the question, and you wouldn't be too far out with this at the end. You would get a range of answers that will be acceptable, as long as they were between two particular values, to allow for those kind of rounding errors and rounding differences to come in. Question 26. The table shows information about the heights of 80 plants. So we've got heights given in groups. We've got 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60 and 60 to 70, with frequencies for each of those: 7, 13, 14, 12, 16 and 18. Part A, find the class interval that contains the median. So class interval, first of all, just a fancy word for group. So one of these groups contains the median, and the median then, one of these averages a value denoting the dead centre of the data. It is the middle value, and it's the middle value after the information has been put in order of size. Well, this information is already in order of size, because we're starting with the smaller heights, and then we're moving up to the larger heights, 10 to 20 first, then 20 to 30, 30 to 40, and so on. So they're already in order of size. We're looking for the middle value. There are 80 plants in this table. Some of them in each group, but there are 80 in total. If we're looking for the median then, the 40th plant will be the middle value. So we're looking for the 40th value in the table. The first 7 plants are here. The next 13 are here. So by the time we get to the end of this group, we have gone through 20 plants. 7 in the first, 13 in the second, so that's 20 plants in total. Then another 14. So that takes us up to 34 plants. And then another 12, so that takes us up to 46. Oh, and look at that, we've passed the 40th value. So the first 7 are here, the first 20 are here, the first 34 are here, and the first 46 are here. That means the 40th value will be in this group somewhere. So the 40th value, the median value, will be in the class interval 40 to 50. H is between 40 and 50. Part B. On the grid, draw a frequency polygon for the information in the table. Frequency polygon, a little bit like a bar chart, but using crosses marked on a grid rather than bars. Only thing we've got to remember is that we are dealing with grouped data here, not single discrete values. So we need group data, which means we need to plot the frequency. Notice that we're given a frequency axis here. We need to plot the frequency at the midpoint of the height classes. So the first height class is 10 through 20. So we need to plot that frequency of 7 at a height of the middle value of 15. So 10 to 20, 15 will be there in the middle, and we need to plot a frequency of 7. Right, tricky frequency scale on this one. So there's 5 and there's 10, which means that this midpoint is 7.5. Each square then is going to be a 0.5, 5.56, 6.57, 7.58, 8.59, 9.5, 10. So each little square is a 0.5 jump. So I need to be at 15, and then at a height of 7, so 5, 5.56, 6.5, 7. And I'm going to just put an X there. Next one, 20 to 30. So I need to plot that at 25. Well, halfway between 20 and 30 is there. I need to be up at 13. So that will be 10. That will be 12.5 in the middle, so 13 will be there. Next one, 30 to 40. So I need to plot that at 35. Well, 35 and a height of 14. So there's 15. That will be 14.5. That will be 14 there, counting backwards. Next one, 12, 40 to 50, so I need to plot it at 45. So from 45 up till 12, well that's 10, that's 12.5, so back one will be 12. 50 to 60, so I need to plot it at 55, I need to go up to 16. So there's 15, 15.5, 16. And then 60 to 70 finally, I need to plot it at 65 up to a frequency height of 18. So there's 17.5, so there's 18. There are my crosses marked. The final thing I need to do to make this a frequency polygon is I need to just join up the lines. Drawing the line to join up the points. Nice straight lines with a ruler. And there we go. Question 27. Sean has drawn a time series graph to show the numbers in thousands of visitors to a fun park. We've got a number of visitors in thousands up the side, and we've got year 2016, 2017, 2018, and then some other numbers on there as well. Write down 2 things that are wrong or could be misleading with this graph. There are 4 things we could choose from, so you can choose any 2 of the following. First thing, this axis is labelled year, and we've got 2016, 2017, 2018. First thing, this axis is labelled year, and we've got 2016, 2017 and 2018. That's fair enough, that's nice and clear. But what are the 2, 3 and 4? Are they months? Quarters? We don't know. It's not very obvious. So, first thing, not clear. What 2, 3, 4 are above the years is the first thing you could have. It's not clear what they are. They're not labelled. They may well be relevant, they may well be sensible, but they're not labelled. We don't know what they are. Second thing, slightly harder to spot, but 6, 6.5, 7, 7.5, 8, 8.5, 9, 10. If we're having a scale on a graph, we generally want the scale to be consistent or to be really obvious if it hasn't been. Inconsistent scale i.e. no 9.5. Third, curved lines. We can have curved lines in a graph. It is possible, it is allowed, but they tend to be smooth curves, and these aren't particularly, and we tend to only be able to draw smooth curves when we can show that the information is changing smoothly. Numbers of people are separate, discrete values. They are not something continuous. Something continuous with a smooth curve might be something like the rate of water coming out of a tap, say. The water will constantly be coming out of the tap. The speed may change, but it will change repeatedly. It will change continuously from one point to the next through time. Whereas these are separate, discrete values. They are numbers of people in thousands taken at individual points in time. So we cannot draw curved lines for it, because curved lines suggest a gradual continuous change, whereas straight lines moving from one piece of data to the next piece of data to the next piece of data. So should not have curved lines. And the fourth thing, and this is a really subtle spot, here. 6 and 2 down in the corner of that graph. Even though there is no data given there, the fact that they are both down there in the corner, that suggests to us that those 2 values are true at the same time, that those 2 values match up. And that might not be the case. We don't actually have any information given for 2, but the fact that they match up does suggest that there are 6,000 visitors in this 2, whatever it happens to be, because they've been put at the same point on the graph, on the axes, where the axes meet. So the axes suggest that there were 6,000 visitors in 2016 too. This may not be the case. That one is a really subtle spot. The other 3 are more obvious, and the other 3 are probably more like what you're going to go for. But any 2 of these things will get you the marks. So you either want to say it's not clear what the 2, the 3 and the 4 are. They could do with a label. There is an inconsistent scale. We shouldn't have curved lines. Or that the axes suggest that there were 6,000 visitors in 2016 too, which may not be the case. Question 28. The diagram shows a hexagon. The hexagon has 1 line of symmetry. Right, before we read any further, we're going to have a look at the diagram. Then we'll read the information underneath and see if we've picked out what's there. So let's just have a look at this diagram. First of all, we've got a hexagon. Hexagon, 6 sides. It's not a regular hexagon, but it is a hexagon nonetheless. It has 1, 2, 3, 4, 5, 6 sides. Grab my highlighter because I'm going to pick out some things that are useful in there. First of all, we've got this angle here, 117 degrees. That's presumably going to be important, otherwise we wouldn't have been given it. We've also got these little dashes here. And we've got these double dashes here. Dashes on lines mean that they are the same length. So these two lines are the same length as each other. We don't know how long they are, but they are the same length as each other, because we've got single dashes matching them up. These two lines here are also the same length as each other because they are paired up with double dashes. But note that this line and this line are not the same length necessarily. What else have we got? The hexagon has one line of symmetry. Well, we could probably work out where that is. If these two lines are the same and these two lines are the same, the line of symmetry must be down the middle. That's of use, because if that angle is 117 degrees, then we could make a reasonable guess what that will be. If they are symmetrical, that will also be 117 degrees. We're getting ahead of ourselves though. Let's look at the rest of the words in the question and see that we've spotted everything. First thing, FA equals BC. Well, FA is this line here and BC is this line here, and they are indeed the same as we noticed. EF equals CD, E to F and C to D. Well, we also noticed that. That's the two double dashed lines being the same length. Angle ABC equals 117 degrees, A to B to C. Angle at B, when running from A to B to C, there we go, 117 degrees. We'd already noticed that in the diagram. Now, this one here, we would have no chance of knowing that other than from the words. So this is why it's important to also read the words. Angle BCD is 2 times angle CDE. Let's identify those angles first of all. So, 3 letters, we move from 1 to the second to the third, and it's the angle at the middle one. BCD. Right, B to C to D. So that's this one here. This one here, however big it is twice as big as CDE. C to D to E. So this one here. So this one, which I'm now going to give 2 circles to, is twice as big as this one here. We don't know how big either of them are, but this one is twice as big as this one. Work out the size of angle AFE. A to F to E. So that's this angle here, and this is the one that we are looking for. This one here is the angle that we are looking for. So how are we going to go about that? Right, it's a hexagon. With these angle questions, we're only given one of the angles. And I suppose, okay, we know another angle there as well. We know that this one is also 117 degrees. We could probably fill that one in too. So in fact, there's our first step. Now let's go FAB. If you want to use the angle notation. Alternatively, we could just label it as number 1. 117 degrees by symmetry. It must be. The line of symmetry down the middle, that must also be 117 degrees. Another key takeaway of that is that these two angles must be the same, and these two angles must be the same. So the symmetry stuff is quite useful, because that means that if this one is twice as big as this one, then this one must be twice as big as this one. And the relationships match up on either side of that line of symmetry. Okay, it's a hexagon. We've got 2 angles now that we know inside the hexagon, and 4 that we don't know. It would probably be helpful to know what we're working with overall, what all 6 of the angles add up to. It is a hexagon. I am going to draw a very quick sketch of a hexagon. There is the hexagon that we're working with. A very, very quick sketch. To work out the total angles inside, well, I could probably do this splitting up into triangles thing again. I'm going to pick a corner, and I'm going to draw out to each other corner in turn, always heading back to the original corner that I've chosen. 1, 2, 3, 4 triangles. This still works even though it's not a regular hexagon, because I've split it up into triangles from one corner to all the others. So the total interior angles will be 4 lots of 180 degrees. Why 180 degrees? Because angles in a triangle add to 180 degrees. 4 times 180 is 720 degrees. Now we can't do any of this kind of dividing the 720 down because the angles are all different sizes. It's not a regular hexagon, but we at least know that all the angles inside there add up to 720 degrees. Because angles in a triangle add to 180 degrees. Okay, next step then. Well, let's try and do a bit less with this. We're dealing with 720 degrees in total. But really, we don't necessarily have to look at the whole hexagon. Because of that line of symmetry, because these two angles are going to be the same, these two angles are going to be the same, and these two angles are going to be the same, half of the 720 degrees will be contained in these three angles, and half of it will be contained in these three angles. So let's just ignore half of the angles. Let's ignore those three, and just focus on the side that we're interested in. So how many degrees will be split across these three? Well, half of the 720. 720 divided by 2 is 360. So we only need to work with 360 degrees now. By symmetry. Now the 360 degrees is split across the 117 and these two unknown angles. And we know something linking these two angles because the stuff linking these two angles is the same as the stuff linking those two over there. That this one is twice as big as this one. So really we need to know how much information is just contained in those two angles. So why don't we do 360 take away the 117, which will leave us with 243 degrees. So there's now 243 degrees split across these two angles, where this one is twice as big as this one. So we need two numbers that add up to 243, where one is twice as big as the other. That's quite a difficult spot. But really, if we've got this is twice as big as this one, if we split this 243 degrees into three parts, that can have one of the parts, and that can have two of them. And this number will then be twice as big. So step 5, 243 divided by 3 is 81 degrees, which means this one must be 81, and this one will be two lots of 81, is 162. Because that's our step 5 there. So our step 6, do this one up here, two lots of the 81 is 162 degrees. Which angle did we need to give? We need to give the AFE, A to F to E, that's this one here, 162 degrees. And just to make it really clear what we've done, how do we know that this relationship is the same as on the other side? By symmetry. AFE is 2 times FED. By symmetry, matching up to the other side. Question 29. Jeremy has to cover 3 tanks completely with paint. Each tank is in the shape of a cylinder with a top and a bottom. The tank has a diameter of 1.6 metres and a height of 1.8 metres. Jeremy has 7 tins of paint. Each tin of paint covers 5 metres squared. Has Jeremy got enough paint to cover completely the 3 tanks? You must show how you get your answer. Okay, to work out whether he's got enough paint to cover the 3 tanks, we need to know 2 things. We need to know first of all how much paint he's got, and second of all how much paint he needs. How much paint he's got should be easy enough to work out. He's got 7 tins of paint, and we can use that to find how much area he can cover. He can cover 5 metres squared worth of surface with each tin of paint, so we can work out how much surface he can cover in total. To be able to compare, we need to know how much surface there is of the 3 tanks. We need to know how much surface there is on 1 tank, and thus how much there is on 3. Now we're talking about surface, we're looking at metres squared. We must then be talking about surface area. So there's our direction. Our first step is going to have to be finding the surface area of 1 tank. So that we know how much surface there is on 1. We can then scale up to find how much surface there is on 3, and then compare with how much surface he can cover with the 7 tins of paint that he's got. So step 1, we're talking about surface area. Now to find the surface area, we need to split the shape into the different faces and look at the area of each of those. So on this cylinder, we've got the circle at the top, we've got the circle at the bottom, which is exactly the same, and we've got the rectangle wrapped around to make the side. We're going to look at the circle on the top first. So the area of a circle is found by taking pi, this number, linking the circumference to the diameter of a circle, pi 3.1415 and so on. We're going to take this number pi, we're going to times it by the radius, and we're going to times it by the radius again. It's not 2 times the radius, that's the radius times the radius, they are different. So the area is going to be pi times the radius of the circle. We are not given the radius of the circle in the question, we are in fact given the diameter. We know it's the diameter because it says diameter of 1.6 there. But we need the radius. It has to be the radius for an area. That's what the formula needs. But there is a link between radius and diameter. The diameter is the distance from one side of the circle to the other through the middle. The radius just runs from the middle to the outside. So the radius must be half of the diameter. If the diameter then is 1.6, the radius will be 0.8. So we need pi times 0.8 times another 0.8. On our calculators then, Shift and times 10 to the x, or your EXP button, because they are the same thing, to get pi up on the screen. Times 0.8 times 0.8. Turn it into a decimal, because we're going to work with decimals through this. 2.010619 ... meters squared. I'm going to put my units on, so I'm keeping track of what that is. And I'm going to keep more decimal places than I need so that I can round at the end. But there is the area of the top. The area of the bottom will be exactly the same, because it's the same circle, so we don't need to work that out again, we can just copy that directly. 2.010619 ... meters squared. We now need to work out the area of this wrapped round rectangle that makes the sides of the cylinder. So we need 2 things to work out the area of a rectangle. We need a vertical dimension and we need a horizontal dimension. We need an up, down, and we need an across. The up, down is just going to be 1.8 meters because that's the height of the cylinder, so we're given that in the question. This one across the bottom though is harder to find, and we're going to simulate this with the tracing paper. I'm going to use this. There is my rectangle then. We've got the 1.8 up the side. We need to know what this dimension is across from left to right. And I'm going to imagine wrapping this up to make the cylinder. And there we go. Now what happens to the top edge when we make the cylinder? There is the top edge along the top there. When we wrap it up to make the cylinder, it makes the outside shape of the circle. It makes the distance around the outside of the circle. It makes the circumference. So however long this is, along the top or the bottom, it is exactly the same length as the circumference of the circle. So why don't we work out the circumference of the circle? Circumference of a circle is worked out by taking this number pi, timesing it by the diameter. That's what pi is, remember, it's the link between the diameter and the circumference, the number of times that diameter will fit around the outside of the circle. Think piece of string. So we take pi, we times it by the diameter, pi again, the diameter is 1.6, so we're going to do pi times 1.6, pop that in our calculators, pi times 1.6, and that will come to 5.02654 ... meters. Can work out the area now. The area then will be 1.8 times by that 5.02654 that we've just found. And that's going to give me 9.04778 ... meters squared. I can now use those 3 things, those 3 numbers, to find the surface area. So the surface area must be those 3 areas added together. So it will be 2.010619 plus another one, 2.010619, plus the 9.04778, and that will all come to 13.06902 meters squared. Now that's the surface area for 1 tank. I need to find the surface area then for 3 tanks, because that's the total amount of paint that he will need to use. So step 2 then, 3 tanks, so 3 times 13.06902 meters squared will be 39.2070 meters squared to cover. That's how much surface he needs to cover with the paint, 39 meters squared. He has got 7 tins of paint. Each tin of paint can cover 5 meters squared, so he can cover 7 lots of 5 meters squared is 35 meters squared. He can cover 35 meters squared, but he needs to cover 39 meters squared. So has he got enough? No, he hasn't. So our final answer then, not enough paint to cover the tanks. To get the 5 marks, you'd need not enough paint to cover the tanks, backed up by the 35 and the 39. Otherwise, I would suspect that there will be a mark for getting the area of the circle, probably a mark for using the circumference, probably a mark for finding the total surface area, and probably a mark for the 39.2070. And then the final mark for having this not enough paint to cover the tanks with those 2 numbers as backup. And finally, question 30, solve the simultaneous equations. 3x minus 4y equals 11, 9x plus 2y equals 5. And you might quite rightly be asking what a simultaneous equation is, or rather what simultaneous equations are, for they are a pair of them. Perfectly reasonable question to ask, given that I've never mentioned them before, because this is in fact the second of only 2 topics that I decided not to bother talking about. Given that this is the first and only time they've been mentioned across the 3 papers, and the question is worth 3 marks, a whole lesson's worth of talking about simultaneous equations for the sake of 3 marks didn't feel worth it, particularly because they are on the top end of algebra. The stuff we covered in algebra is already difficult enough without adding this in as another topic. If you wanted to go and read up on them, you could well do. They are solvable through a series of set steps. There is a set method to them, but it's not really worth the bother, especially not for 3 marks. There are other places, better places to pick up marks that are easier to get. So we have in fact finished, because we can just skip this question.